So this is session 4 of CuR Mini, and today we'll be finishing up on the motor and sensors that we didn't get to cover last time, and also I think we covered how to program in Arduino last time, and I did a demo, but I just found some slides quite useful from last year, so I decided I'll include them anyway. And today's session, I think, will be a rather short one, as we don't have that much planned. We are like we're in good progress. I think I basically walked through most of what's covered in this slide, but if you would like to have something to read along, this is quite useful. So this is basically the Arduino IDE. It's from last year, so it's one of the older versions of Arduino. And yeah, you plug in your board and you find it through the tools to activate it. Those buttons, I think I've introduced their features already. Arduino is it's almost identical to C++. It has to be compiled before you run them. You press this to check the code for error and this to compile and upload. This is the serial monitor. It's quite useful. It's like it shows the console that you can use the print function to check any values that you are trying to print. There's the setup and there's the loop. Setup's usually the variable initialization. Loop is for repeated code. So mainly 5 types of variables. You need to define all your variable types before you use them, different from Python. And there's int, float, character, string, and Boolean. And actually, I believe character is similar to integer. It's just shorter integer. They are like interchangeable. But you usually store letters with character. And to store strings, use the string. Cool. While loop, for loop, actually, I don't really want to go through this. I think it's just some really basic knowledge for any type of coding. You can just, if you're unfamiliar with this, you can just search for while and for loop examples. Functions. Yeah, as I've said last time, the functions, there are 3 main characteristics. There's the name, there's the parameters, and there are the return types. And setup and loop are 2 special functions. They are functions as well. Void is their return type. They don't return anything. Their name, setup, and loop, and their parameters. They don't take in parameters and they don't output parameters. They're just like whenever you compile it, they will be ran automatically. Oh yeah, and you do need to define the data type of your input, of your parameters as well, input to the function. That is just another feature of C++, I believe. This part is more on how you can organize your code structure, because you might not want to have all the code in a single file to run. You might want to have like your own library and just import them through using external variable initialization. But it's up to you, because this is not really that complicated. But if you're someone who prefers to keep your code tidy, you can look a bit more into how to use the headers and source files to make your code more structured. Yeah, and a bit more on GPIO, because I think I didn't explain it that carefully last time. Those pins, they are the analog pins A0 to A5, or you can call them by their digital pin number, which is 14 to 19 as well. Those are digital pins from 0 to 13, and basically all of them are general input-output pins for, they can all serve as digital input-output pins, meaning that even those are saying that they are analog pins, you can still use digital read or digital write on them. So digital write is basically output, and digital read is input. And you can only use analog read on the analog pins because they have inbuilt analog to digital conversion, meaning that they can convert an analog number into something that an analog value 0 to 5 volts into something that the Arduino recognized. And you can read between 0 to 1023 because the ADC, the ADC converter is a 10-bit ADC converter. So that's the analog values you can get. And for analog write, that is basically the PWM, pulse width modulation, where you use rapid changing duty cycle to simulate an analog output. And they can only be done on the digital pins, which has a curly line in front of them. And I believe there are 6 PWM pins in total. Other than that, they are all identical. Yeah, I think that's it for the coding and micro Arduino bit. And today's main focus is on the motor driver. And as long as you understand that, it's like the hardest bit of the robot, I would say. So first of all, it's got a lot of pins here, and I'll show you how my top chassis looks like. I'm not sure. So there's basically all of the pins are connected, so it's quite complicated in terms of wiring, but in terms of how it works, it's not that complicated. What it does is it connects to the 2 motors that you have, and it basically controls how much current is applied to the motor. I think I mentioned before I think it was in the second session, that the motors, so you will have one of those angled, this is one of those angled motors or a straight motor. They're both similar. They have a gearbox within, and there's only 2 pins that you connect it to. If you just connect it to, say, a power supply, it will just have a fixed power input to it, so it always spins at the same speed. Use a motor driver to control the current supplied to it, so that actually I think it's the voltage supplied to it, so that you control the power input to it, and therefore you can control the speed of your wheels, and by controlling that you can make your robot like turn or go forward and backwards, stuff like that. And the thing to control it is the motor driver. First of all, the pins here, A0, A01, A02, or it might be A01, A02, doesn't really matter. That means the input, the output from the motor driver, and that is connected to your motor. So these 4, they are the output. They are connected to 2 of your motor. Those are the input. So A in 1, A in 2, what they do is actually let's talk about PWMA first. That's controlling how much power that goes into your motor. For example, if the full voltage is 5, which is that when you put 255 for the PWMA, and the reason for it being 255 is because that's the maximum value for analog write. That is equivalent to a digital write with a value of high. If you put 255 for PWMA, it will be full power supplied to between these 2 pins. So, and that means your motor is going at full speed. If this is at 127, it will be going at half the speed. so on and so forth. And that is basically controlling, it's basically like an on and off button. They require digital signal from your Arduino, and if they are like different value, for example, you put high for A in 2 and low for A in 1, you actually get a voltage here. If they are the same, for example, they are both high or both low, you won't get anything here. And if you change it from A in 2 being high and A in 1 being low to the other way around, this being low and this being high, it reverses the direction. So it reverses the voltage here. And that means your motor will be spinning in the opposite direction. And yeah, this is basically the graph for how it works. So you can see if you have the both input being H, which is high, you get low voltage from out, and that means it's a break because the voltage connecting to the motor is 0. And if you do too low, it's a stop. It's basically similar. If you try them out, the effect is like similar. If it's low and high, and if it's low and high, you still need the PWM to be high. So if you turn this to 0, it will be like there will be no voltage anyway. So, and if you set the PWM to a reasonable value, CCW means counterclockwise rotation, and if it's the other way around, it will be counterclockwise. But in reality, depending on how you wire it up, it doesn't matter like whether it's clockwise or counterclockwise, because you can just try it out, and in case it's not spinning in the way you expect, you just change. You don't even need to change the wiring. You just change the way you define the pins in the code. So say you just switch the 2 pins, and that will reverse the direction. Sorry, you switch the pin here because that's the output and that's fixed. Next, about the power supply, that's the pin for the signal control. Those are the pins for the signal control of the motor driver. In terms of power supply, VM, that is the motor voltage. That is where your battery supply comes into play. So it requires a power of 2.2 volts to 13.5 volts. We are using 4A batteries in the battery case, which is in series, 6 volts to supply power. And VCC is the logic voltage. That is what your Arduino supplies. So all the other sensors that are connected to the Arduino, for example, the IR sensor, the ultrasonic sensor, they all got VCC, and it's the same VCC. And there is a ground, and the ground is a shared ground. There are 3 ground pins, and they are all the same and connected, so you can use either of them. And there is a standby pin. So if you look at this diagram, when it's on standby, it's always a break, and basically standby just disables the motor. And sorry, I got it wrong. Standby has to be on high for it to work. If it's on low, it's on standby mode, and that means it won't do anything. And this is just to save power. So when it's on standby, it just won't do anything. And for our purpose, we don't need a signal to control it, to leave it on standby, because we can just turn it on and off. When it's off, it's standby. So we just what you can do is you just connect the standby to VCC. That means it's always a high signal at standby, and that means it will work normally. What else? And yeah, and the purpose of this not only is to control to have a PWM option to control it, but the reason you're having two power supplies instead of you may be wondering, why don't we just connect VCC to VM? Because VCC is also 5 volts, and that's within the range of 2.2 to 13.5. The reason is that you don't want to use your Arduino to supply the motor because they draw quite a lot of current. They're actually doing work. And that's why you have separate power supplies. Oh, and by the way, speaking of this, because like I received some questions on it as well. The battery, you have 2 battery supplies. One of them is the 9-volt battery, and the plan is to connect that to the Arduino, and you got the 6-volt battery and the 6-volt battery case, and that is to power the motor driver. And theoretically speaking, you can power the Arduino with the 6-volt battery as well. You just do it through the but like that will leave you with no power for the motor driver. So yeah, just to clarify that. That's why you are having 2 battery packs. Great. And if you're interested, this is how the internal structure works. Those are switches that are basically transistors, and they are connected, so they act like a switch. So when you power them, they will allow current to pass through, and they are diodes to like control the way the current can flow. So you can see only when it's like that mode and that mode, current flows through the motor. Yeah, it's only this 2 mode. Yeah, actually, I might not be totally correct, but this is kind of how it works. And as always, if you want to learn more about how the motor driver works, do go have a look at the data sheet. But if you just want to make your robot work, it's sufficient to just look at this graph, and this graph is here. You can find the graph here. Yeah. And finally, we got 2 sensors that uses I2C protocol. So what is I2C? It is a 2-wire communication protocol where a master device can talk to many slave devices. So what does that mean? That means that you only need to use 2 digital pins to control all the slave devices here. And actually there is an upper limit, and I think that is 127 or 128 devices. I'm not sure about the end bits because you need to store the address. They have to be unique address. So basically the Arduino is the master, and you got 2 components that are the slaves. And I've got it connected here. I'm not sure if I can show it on the screen. Oh, this kind of blind. Okay, so I'll just say that it's connected to A4 and A5. I can't really show it because the wire is quite short, and you can connect 100 of those devices just using those 2 pins. So it's really kind of amazing, and we'll talk more about I2C devices next time. Right now, I'll just demonstrate how you use the code for it. And yeah, let me just bring up the code. So all of those codes are written by someone else, and it is the same for many of those Arduino projects. Most of the whatever you're trying to use, most likely the code is already done by someone else. So it's much easier to just try to find it online than trying to work with all those stuffs, because especially when it comes to I2C devices, like you see that with only two wires or two pins, it can do so many stuff. Like it can, for example, for the color sensor, it can measure RGB values, it can measure intensity. So it will be really hard if you are trying to write the code yourself to manipulate the signal and to convert it into basically signals you can work with. Yeah, so here is a demo code that I got online, and basically it uses the Adafruit TCS 34725 library, and you initialize a new object here. Let's try it out. Get it to the right band. That's weird. It's saying that can't find my device. It was working a while ago. Not sure what's happening now. That's really weird. I'll look into this later. Let's try the gyroscope instead. Might be some conflict with the I2C. Oh, disappeared. Okay, get it to the right band. Come on, is it? Oh, it's working. So for I2C devices, as you're only using two pins for the data, you still need the power. You need to connect it to VCC and ground. And other than that, you only need two pins. It's similar to ultrasonic sensor, two pins for the signal and two pins for the power. And 8 pins on it. You can put the SCL and PA. I really want to try to see if I can put it to the camera. And if we monitor, if you look at the console as well, you can see that for the Y value, it's almost the same as gravitational acceleration. Let me just put it upright. There you go. So that should equal to the gravitational acceleration. you rotate it, becomes the X for now. If you rotate it this way, it will become the Z. So hopefully that convinces you that it is actually measuring the acceleration. And yeah, you just do some integration to acceleration. You normally just need to use the X and Y axis, because when you plug it to the breadboard, it's going to be like that. That means that Z is like going this way. So that's measuring the vertical acceleration. And yeah, for the rotation, you normally use the Z rotation, I think. Let's see if the light sensor works now. Also, always be aware of this line. So that will tell you what frequency to use when you're using the console. Yeah, I really want to just do this demo in the session, so you kind of know what the output will be like if it's working properly. Cool. I think it's working right now. So this gives the intensity and RGB values. It is refreshing quite rapidly right now. Quite easy to change it. There's just one parameter there. If we bring something close to it, it will show the color change. And what you need to do is that you don't really need to know what they do exactly. You just need to see, just do some experiment to see which one will actually like help you pick up the target, and that's it. Just find, so just through trial and error, you can find the limit of the sensor. And yeah, I won't be doing a demonstration for the motor driver because it takes quite a long time to wire it up. But in case you got into any trouble with the motor driver, you can always speak with your supervisor. And let me just get the code as well. I mentioned this in Slack, but in case you don't know, I created a repository for all the code for the components. And note that they are just demo code. So if you're gonna make your robot work, you have to think of how you use the data collected. For example, for the line follower, the code is only for how to print out the value detected by our sensor. You need to think about, with that value in hand, how would you adjust the values you input to the motor driver to make the robot do something different than it was doing to it before. So that's the challenge. But just think of them as, say, just demo code to help you know which functions to use. But the way you use the results of the function is the challenge that requires some thinking. And finally, I think this is also based on some questions, because there were some questions about why are there different screws. The mechanics component, I'll just show just share my screen of the CAD. And there are mainly just 3 types of screws. For the standoff, they are in a separate packet. It's M4. M4 meaning they have a diameter of 4 4mm. So it means that that is 4mm wide. The hole at the bottom is 4mm in diameter. And similarly, they use M4 screws and nuts. For the rest of the hole, like here, they are all 3mm M3, and you can use different length ones depending on the situation you are at, but most of them are M3 times 12, which means that they are 3mm diameter and 12mm length. That's just like one of the standard sizes. And for the motor, just here, slightly smaller because the hole on the motor, on the servo, sorry, is slightly smaller. So we use M2 for that. And I think that's it. Include like even the mount holes on the Arduino are M3. So most of them are just designed as M3s. Oh yeah. In terms of missing components, I've ordered them, and I think because some of the kits are missing, some of the kits are not, and I've ordered some. I think I've ordered enough, and they will be arriving like within, I think, before tomorrow. So I'm not sure which works best. I'll definitely be present in Dyson Center Friday afternoon. This time I checked my schedule. Sorry for last time because like I said during the session that I will be at Dyson Center at on Friday, but something clashed. And this time I promise I've double checked. This time I'll definitely be there. And oh yeah, I almost forgot to mention, because the light sensor I gave out is like still with the pin and the breakout board, so it's not soldered. And I've said that I want to give you the choice as to whether you want to solder it yourself to have the experience of doing so, or if you're afraid of messing up, I can do it for you. And ideally, I can do it on Friday, this Friday. And I've also bought some of those new screwdrivers because we didn't have enough when we were handing the kits out. So I bought enough for everyone. So if you want to collect one of them, you can come. And yeah, so the action points basically being to test out the components mentioned today, especially the motor driver. It's good that you fully understand how to do all the wiring and coding. The code for the motor drivers is included on the GitHub as well. And the light sensor and gyroscope will be, you can try to see how it works. And I've allocated the supervisor. They're on the same file that you check out your teammate. So I added a column here that says your that is your supervisor. And yeah, I think that's basically it for today. And so I'll be at the Dyson Center on Friday. Yeah. And yeah, I think the supervisors will be checking with you to see if you tried out all the devices or not. And if you got any questions, you can ask. Yeah, we can stop the recording.